Now let's look at the first example problem for segment trees. This is a lead code problem called the range sum query mutable. So the problem is we are given an array nums and we are given two types of queries. The first type is we need to update the value of the array at the particular index. And the second type query is we need to return the sum of a range. So we're supposed to implement this num-array class. There's a constructor that initialize the object with integer array nums. And there's update, which update the value of this to be val. And then there's some range which return the sum of the subarray. So this is essentially a specification for a segment tree. So we just directly apply segment tree to this problem. And this is my code using the KCTL template. So because we are writing the class, which is essentially a segment tree, so I didn't include this type as a separate class. I basically just pull the code for a segment tree from the template and put it here and make some modification. So because we are dealing with int, so I didn't use I didn't have the type df for defining the type thing. I just directly plugging in. And also it's sum, so I didn't define a separate function. So in the constructor, we fix the size n, which is determined by the input vector, and then we initialize a size 2n array for the segment tree. And for I need to initialize the value. So one way to do it is you simply call update for each of the value. So because update is log n, when you initialize, you need to log in. You need to initialize n value, so it's n log n. That which should be okay. But here I just want to illustrate. You can also directly initialize everything in linear time. So first is put all the value in the input array into the second half of my vector. So this is just doing this loop, and then going backwards for each of the internal node, I compute the value at the sum of the two child nodes. So because I'm going backwards, so by the time I'm computing the node I, the children already computed. So this in linear time initialize everything. And the update is the same as the template code. And the query part is here. So because in this problem, E is included in the range. So in order to use the code, I just increment by 1. I think other things, it's essentially the same as the template, except I replace the function f with just the plus. So that's a straightforward application of segment tree. So this is kind of the first application of segment tree is support this. And next, we're going to see that segment tree can be used to solve other problems that may not be obvious from the beginning. It may not be obvious that it have this range query and point update.